recording, so let's get started. So 9.1, you saw these in grade 11. If you were in my class, you saw this. I gave you parts of this in chapter 6. So in chapter 6, we did reciprocal functions. So I got you to graph y equals x squared minus 4, and then I got you to graph f of x is equal to 1 over x squared minus 4. So that was chapter 6 of grade 11. So now we're going to take this another step further. So we're going to build on what you know from grade 11. Okay? And we're going to use transformations as well. It's kind of painful. Okay, so here we go. Exploring a rational function. The difference between last year and this year, or if it's all the same year for you, is that we're going to have x's on top and on bottom. Okay? So last year we didn't have any x's on top, we just had the number 1 on top. This year, we're going to put some x's on both top and bottom. And you're going to have the best time of your lives. It's going to be great. All right. I don't know why my pages are all pulled apart, but that's okay. So what it's just saying is you can have like this would be like x plus 2 on top and maybe x squared plus 4 on the bottom. Okay? So x is on both top and bottom. P of x and g of x are polynomials. And the domain of the rational function consists of all values of x. So g of x cannot equal 0. But does that make sense to everybody? We can't have a 0 denominator because then it will be undefined. Okay? So, and then we're going to deal with some asymptotes. It's a straight line that the function closely approaches but never is met or crosses. But we know that about asymptotes. That's old hat for us. Okay, so now here's my guidelines. Find and plot the y-intercept, evaluating f of 0. So what does that mean? You're going to substitute 0 in everywhere you see x. You're going to find the zeros of the numerator. You're going to find the zeros of the numerator by solving the equation where the numerator equals 0. You're going to plot those intercepts. Okay, you're going to sketch the corresponding asymptotes by finding the non-permissible values. Those will be your vertical asymptotes. So non-permissible values are where we solve for x cannot equal in the denominator. Those are your vertical asymptotes. So those will be like x cannot equal 2, x cannot equal 3, and you will draw in a vertical dashed line indicating that that's an asymptote. Now your horizontal asymptotes, so running left to right. Okay? This you have to memorize. Okay, so this part you have to memorize. And all we did last year was part A. If the degree of p of x, so if the degree of the numerator is less than the degree of the g of x, so of the denominator, y equals 0 is your horizontal asymptote. If you're doing calculus right now and you want to use limits to prove it, where x is approaching infinity of the limit, you can. That's fine. I will do that if that makes more sense to you. If you're not taking calculus, you've got to follow these rules. B, if the degree of the numerator equals the degree of the denominator, then the line is y equals a over b is your horizontal asymptotes. Those are the leading coefficients of p of x and g of x. And we'll do an example with those, so that'll make sense. Actually, I'll do one right now. So if you have y equals 2x plus 4 divided by 5x minus 4, what's the degree of the numerator? What's the highest exponent on the numerator? 1. It's the invisible number 1. What's the degree of the denominator? Also 1. Good job, everybody. So the degrees are equal. The numerator and denominator degrees are equal, so my horizontal asymptote is going to be y equals 2/5, because they're the leading coefficients. attached to the leading coefficient. Yep. Yep. So it sounds really complicated, but it's really not. So if they are the same degree, so in a case like this one, like this example would be like y equals x plus 2 over x squared minus 1.
Is px on top?
Px is, so that's this right here. Okay, px over gx. So what's the degree on the numerator? 1. What's the degree on the denominator?
2.
So p of x is less than g of x. So the asymptote for this one would be y equals 0.
Always?
When the degree of p of x is less than the degree of g of x, then it's y equals 0.
Like, no matter what? Like,
When the degree of the numerator, yes, in that situation, yes. Okay, so if the degree of p of x is greater than the degree of g of x, the graph has no horizontal asymptote. So a situation here might be x squared plus 4 over x minus 2. Degree on the top is a degree of 2. The degree on the bottom is 1. So there would be no horizontal asymptote. Where would the asymptote be, vertical asymptote be for this one? X equals 2, because you're looking for the non-permissible value on the bottom here. So it can't equal 0. The denominator can't equal 0. So I would set that up as x minus 2 equals 0. Solve x equals 2. That's the equation of the vertical asymptote. That would be your NPV. Okay? So what would be my vertical asymptotes here?
1.
And?
I don't know.
Negative 1. Because I would factor this, right? That's the difference of squares, x plus 1, x minus 1. So you're going to have vertical asymptotes at positive 1 and negative 1. Okay, use sign analysis. Some people don't like sign analysis, so I'm going to say table of values to show where the function is positive and where it's negative, and then use a smooth curve to complete the graph between and beyond any vertical asymptotes. Easy peasy, right? Sounds good? Okay. You guys know what TOV stands for? Table of values. Okay, here we go. You ready? Okay. First of all,
1 over 1.
okay, 1 over x. So let's do our vertical and horizontal asymptotes right away.
There's a 1 on it.
Okay? Vertical and horizontal asymptotes. Let's do our vertical because those are the easiest. So to find my vertical asymptote, really this is just your NPV. So what the denominator cannot be. 0. So we're going to set the denominator equal to 0. We did NPVs last year in grade 11 in the chapter 6. Because if it is a 0 on the bottom,
That's 0 on the bottom?
it becomes undefined at that point, right? We did these in trig graphs too, right? If we put a 0 in for x, how would you graph 1 over 0? You can't, right? So that is a vertical asymptote. So to find your vertical asymptotes, you're going to set your denominators equal to 0 and solve for them. This one's nice just because there's no solving involved. Okay, let's go to your horizontal asymptotes. So for your horizontal asymptote, these are the rules. Those are your rules of degrees that I told you that you had to remember. Pardon? They are not equal. Does it have a variable on the top? So what's the degree of the numerator? 0. Okay.
Is it because anything to the power of 0 is 1? Is that what you're trying to say?
What's x to the exponent 0 worth?
1.
And what's the... So it's y equals 0.
So it's only the degree of the variable and not the number of...
It's always the variables who control the degrees.
Okay.
Always the variables. So does this one have an x on top? If it doesn't have a variable, it has a degree of 0. Okay? If there is no variable, then it has a degree of 0. No variable, degree of 0.
But doesn't that just mean that the denominator is bigger?
Yep. So this is option A. Right? Because P of x has a degree less than G of x. So this has a degree of 0, and this has a degree of 1. So that means, I'm just going to write A here, it's option A, so it's going to be y equals 0. Do you know what I mean? Okay. All right. So we're going to get our handy dandy rulers out. And we are going to put on those asymptotes. So y equals 0. Y equals 0 is just your x-axis. So remember that it has to be a dashed line, although that one you can barely see, which is awesome. I'm going to use an orange one. And so my x equals 0 is my y-axis. Okay, that one you can kind of see. Maybe I'll redo this one. And they should be dashed lines. If you put them on there with a solid line, I will deduct you a full mark. Whew, serious business. Because these are not part of the function, they are invisible boundaries. Okay? Okay, so this is where the table of values is going to come in handy. Okay? And you just want to do the boundaries, and you're going to use your vertical asymptote kind of as your boundaries to do your table of values. Because you know you can't have 0, can't be it. So when I do my table of values and I'm picking my x's, what am I going to avoid? 0, because it's an asymptote. You've already dealt with that. So we're going to pick some values less than 0 and more than 0.
Wow.
It's pretty crazy stuff.
This would have been so much easier in calculus, Miss Scully. I don't know what you guys do.
Well, here's the thing. In calc, they won't let you do the rules. Because in calculus, you've just proven why it actually works. These are rules I'm asking you to memorize. And they work because limits exist. Okay? All right. So if I substitute -4 into that equation up there, what do I get? -1/4. Good job, everybody. If I substitute -2 in there, -1/2. +2, +1/2, +4, +1/4. Yeesh, those are ugly numbers. Okay. I know. Don't judge. Jeez. Okay, -4, I'm at 1/4. -2, I'm at 1/2. Oh, where am I? I'm under. Who left me in charge? Jeez Louise. So I have these two lone little points right there. And I have those two lone little points right there. So it doesn't look like much of a graph, but I will tell you, you don't need much more information than this. So what you're going to do is you're going to connect them with a smooth curve. And what do we know about the function? It's going to head towards the asymptotes, but it's never going to cross them or touch them. So this is headed towards that horizontal asymptote, and this is headed down towards the vertical asymptote. Okay, I'm going to deduct myself a half mark. Anybody see my problem? This is my problem. Anybody see the problem right here? Let me even zoom in. Well, what happened? Is it approaching the asymptote? No, all of a sudden I'm moving down. So look at your graph. Is it better than mine?
Oh, that's so specific, Miss Guy. I'm gonna mess that up.
Yeah, it's kind of a big deal though. Okay. So same thing up here. I'm approaching, and I'm going to say that it continues on, so I'm going to keep my arrows, and those arrows should be headed towards the asymptotes. They shouldn't bend away from the asymptote like I did there. That was bad form. Bad form. Bad, oh bad. Okay. Oh dear. Oh dear, I dropped the graph on the wrong page. Okay, can I flip? No? We do have to label some points, yep. I know, I am not doing good here. Okay. I thought you were going for the pencil sharpener again. I'm like, how did you graph one thing and it's already dull? That's not good. Okay, we good? Okay, this is my least favorite. So Danica, you're gonna get mad because there is one way to do it doing transformations, and then there are the rules that we did on page 1. Okay?
Which one's easier?
I was taught the rules on page 1, so that's the way I've always done them. And then they brought in these stupid transformations, and I had to learn a new way. So if you can tell which way I like better, is page 1, because I know that one more. Okay. Okay, that A value is a constant. Okay, and it represents your vertical stretch.
Oh, look, okay.
It does, well, it always means vertical stretch. Well, yes, and amplitude, but really amplitude is a vertical stretch. Stupid A. H is your horizontal shift, and K is your vertical shift. And these are all based off of
So can H and K also be your joining points?
no. No.
Oh, because you don't really have.
But what will shift is if my asymptote was at x equals 0, and I have a horizontal shift 2 units to the right, what happens to my asymptote? It moves 2 units to the right, okay? So if it was at 0, it's now going to move over to here. And if this was at 0, and I'm going down 4, my horizontal will then move down to 4.
What do they get stretched?
That won't affect the location of the asymptotes.
I feel like I figured it out.
Okay. No, there's no horizontal stretch. We will not be doing the horizontal stretch here. Let's remove B and throw, it's too much. It's too much emotionally for us to handle. B will not be on the next lesson. B is gone. Would it be on the who? I have no clue. I don't, this is not my jam. Just let me do it like page 1 and let me be. Okay. Look at me. All right, okay. Identify some things. What's happening? We have a vertical stretch by 6, right? We are horizontally shifting to right, and we are vertically shifting 3 down. So what that means is it's going to affect our asymptotes. Okay, these move your asymptotes. Asymptotes, finish it. They move your asymptotes. So if my, just the shifts. So if my horizontal asymptote was at 0 and I move it 2 to the right, where is it now? So now it's at,
So are we only gonna do transformation to the one of our x graph?
oh no, silly goose. We're starting. Okay, so, but doesn't that make sense? Because what would our non-permissible value be here? It would be 2, right? So this shouldn't be a shocker to anybody. So this one will move to y equals -3 because it was at y equals 0. Now it's shifted down to y equals 3. So when I ask for the equation of the asymptotes, you need to be able to write the equation of them. Make sense to everybody? Sure. Okay. So the original table was, what was the original table? Yeah, I just don't know if we should do it that way. What?
Do we have to do a table of values?
Yeah, we will eventually, but I don't think we're gonna do, I think we're gonna, okay, just leave it there if you need it and we'll come back to it.
Well, I guess it won't look as ugly with the stretches, the vertical stretches.
It'll look a little bit different. Okay, let's put on an axis here. Or increments, 2, 4, 8, 10. You guys are having way too much fun. Okay, so first thing I'm going to do is I'm going to put on my asymptotes. You shifted. Okay, how do you feel about that? Good? Okay, great. I like it. So now let's do a table of values. And where is the break on the domain this time? It's at 2, right? Our asymptote on the domain is at 2. So we're going to pick values left of 2 and right of 2. Because what's happening at 2? It's undefined, or there's an asymptote there. And you guys have used asymptotes before recently on chapter 5. You did. Yeah, you did.
This year?
Guys, oh my goodness, your tangent graphs. That is chapter 5. That was trigonometry. It was chapter 5. Okay, guys, let's substitute those into the equation, everybody. Okay. -2 is going to be substituted into the equation. Oh, those are going to be ugly. I probably should have picked better ones.
Oh, wow.
It's okay, everybody.
Can we go up by 1? Will that make it better?
No, we're good. Do you want to go up by 1?
Well, yeah, because if you do 3 minus 2, then that's 1. That's like 9.
So you want to do a -3 instead?
I already wrote it.
Okay, up.
No.
Okay. All right, okay. Okay, so let's substitute it into the equation. So we're going to have, I'm trying to find a place so that you can see it because I got it so zoomed in. Y equals 6 over negative 2 minus 2 minus 3. So y equals 6 divided by negative 4 minus 3.
Do we get a calculator for this?
No, you can do this without a calculator. So what's 3 over 2? As a decimal. 3 divided by 2. 1.5. It's a negative 1.5 and you're minusing 3. So y equals negative 4.5. Which is 9 over 2. Absolutely. Okay, can you do 0? Okay, what's 0? Hopefully it's just negative 6. Okay. Okay, so if I substitute positive 4 in there, it should be 0.
This would be a lot nicer if we went by 1 to 10.
True story.
3 over 2 take away
3 over 2. So you have,
4.5.
well, no, it's not. Think about it. You have a positive 1/2, and you're subtracting 3 from it. Yeah. Okay, let me go back to here. I don't have enough room to keep.
So minus 1.5 plus 3.
So this time it is 4 minus 2. So that's going to give me 2. No, it's a 6. Sorry, 6 minus 2, so that gives me the 4. Reduce that to 3 over 2, which we said was 1/2. So 1/2 minus 3. You were, yeah, like. Okay, so let's graph them. There we go. Negative 2 is 4.5, so like right there. And 4 is 0. And 6 is negative 1.5. And what you should see is that you should never have like a negative stacked on top of a positive. Like they should be on different sides of the asymptote. Okay, now you're going to connect the dots. Wow. It's not stupid, it's super fun.
That was almost really good.
Thanks. And all my functions are headed towards the asymptote. Ladies and gentlemen, you have to have both sides in order for this to be a full and complete graph. If you only graphed that side, you wouldn't get full marks for it. Do you guys want to do it with transformations?
Did we not? What happened to my graph? I thought we did.
We didn't.
Wow.
We just did a table of values. Did you want to do it with this isn't transformation form, but
Are we supposed
no, this is one way to do it.
to? Oh.
No, well, probably do structures or transformations.
Which one's easier?
Oh, do we just want to
So you'd look at your old table, and then you'd apply those transformations to your old table's stuff.
I guess both of them are pretty easy.
I feel like this is easy.
This one?
Yeah, this way is easy. But you also know how to do the other way. Like the original table, this was the original table. We had, what did we have? Negative 4, negative 2, 0 was undefined, and 2 and 4.
You know, we could do like our mapping rules.
Yeah.
There, I guess.
Did we get the same math? Yeah.
Yeah. So then if you did the transform table,
Oh.
what's happening at negative 4? What are we doing to the x's?
Adding 2.
We're adding 2, so we'd be at negative 2. That would be 0 My asymptote would move to 2.
Wait, what's the first strategy called? Like, what do you call it? Just table of values?
I don't know, we just substituted into the formula. This one would be 4, and this one would be 6. Now, what are we doing to the y values here? Multiplying by 6, and then subtracting 3. So multiplying this by 6 is negative 6 over 4, and then we're going to subtract 3. So that would be negative 7.5. No, it wouldn't be. Because it would be negative 4.5. So negative 1/4 times 6 minus 3. So this would be negative 4.5. Negative 1/2 times by 6. Negative 3. Negative 3 minus 3 is?
And we're not getting our calculator for this?
No. So 1/2. 1/2 times by 6. 3. 3 minus.
0.
Nice. Good job, Nicole. Didn't even need your calculator for that one. Okay. 6 times 1/4 is 6 over 4, which is 3 over 2, which is 1.5 minus 3. So which way did you like better? Just substituting it into the formula and calculating? Okay. All right. Good job. Good job, everybody. Okay, so is this in transformation form? I did.
We did, right?
I did. I did. Sorry. Sorry. Ouch. Yeah. Did I look at them?
Yeah.
No, I put them in a pile. I put the answer keys with them. I took them home on Saturday. I left them on my kitchen table. And then I brought them back today. And then I brought them back upstairs. So I took them on a road trip. And now they're back home where they belong.
That's where I did my problem with that.
Okay. All right. I know I'm going to get yelled at for this. By Danica. Okay. So you can graph this based off the rules from page 1. Or you need to convert this to transformation form, and then you can graph it off transformation form. Okay, that's a good question. How do I know it's not in transformation form? I know it's in transformation form when there's a constant with a denominator that has an x in it, and then there's a constant being added with no denominator. Like it will be in this format. Like you'll have a fraction with a variable on the bottom, and then you'll just have a number.
Only one x.
I'm sorry, go again?
Only one x for transformation form?
Yes, yeah. So this one we see that there's x's on the top, there's no just constants. So I'm going to show you how to convert it. Okay? I'm going to show you how to convert it, and then you guys can make the decision. I can graph it both ways for you if you want to see how to do it both ways, but we're going to do the conversion now. So I need you to take a big deep breath. Okay? I need you to take a big deep breath. Okay, so we're going to convert to transformation form. That's what we're doing right now. What?
Why are those the numbers that we're adding into it?
Okay, look at my numerator.
Oh, okay. We just.
What did I just do to it?
It's the same.
I just separated, right? That's all I did. Everybody good with that? Please note I put a positive here and a negative here. Okay? Did y'all note that? Y'all? Y'all good? Okay, all right.
Always gonna be plus.
I like to do it that way just so I keep my negative, and it will make sense when we go a little bit further in this. Because I'm just going to keep my 5 as a negative instead of a subtract question. All right, so I need you to look at this first one here with the x. My goal is to get rid of the denominator. So I got to figure out what constant I need to add to the numerator or subtract in order to eliminate the denominator.
Minus x minus 2.
So, okay, so look at this. If I do x minus 2, let's look at that. So let's look at that logically. Can I just cancel those out? No. Oh, a kitten will die.
Wow.
Because do we do this and then those x's and then there's just a 4 left? That's not how we do it, right? You need to have that exact same factor on the top. Okay, let's work it this way. How many x's do I have down here?
Can you add like x squared?
Or we can,
No, you don't want to do
can we
that.
do minus and then bracket
Hold on.
like x minus 2?
No. Okay, everybody just breathe for a sec. How many x's do I have down the bottom?
1,
How many x's do I have on the top?
4,
Okay, so what would I need to multiply x by to get it to 4x?
4.
Okay, good job. Okay, keep that number in your head. So this is a minus 2. What number did I need to multiply? 4. So what is 4 times negative 2? Okay. But what did I just do? I changed the value of that expression. So if I minus 8 from here, what do I got to do over here?
Minus 8.
No.
Plus 8, add 8.
Because what's a negative 8 plus 8?
0.
0. So I didn't change anything.
Okay. Wow.
Okay? So that's the most difficult part to this. So now if I look at that numerator, I can common factor out the 4, and I'm left with x minus 2 over x minus 2. Plus, what happens here? Negative 5 plus 8. 3, and I got to keep my denominator because I'm not canceling it out. Negative 5 plus 8. Okay, so now what do? I'm going to cancel these out. So now we're in transformation form.
Can we do it the other way?
Yeah. So a couple of key things here is your whole goal is to always get rid of this denominator. The one that has, when you separate them, the one with the x, you want to get rid of the denominator on that one. And if this is a subtract 8, then this has to be a positive 8, so it doesn't change the value of that side. Okay? So there's a couple of places that things can happen there. All right. Where do my asymptotes move? Or do you need me to pause for a sec? Time to breathe, okay.
Another way,
Can we do the rules?
Okay. I just want to graph this one, and then I will do it again with the rules. Okay? I'm going to do it twice.
so wait, will you get like your NPV for the bottom?
Well, no, this is in transformation form, so what do we know?
So they move 2, right?
So we're going to have, let's go through them. We have a vertical stretch by 3. We have a horizontal shift. Horizontal shift
2 right,
to right. And a vertical shift
4 up.
4 up.
So wait, horizontal shift with the x-axis comes the right story now?
No.
Like, right?
No, because
Oh,
no, it's still consistently bad. It's still consistently bad. Okay, so What's happening to my asymptotes? Where are my equations now?
X equals 2.
X equals 2
X equals 4.
and
Or
y equals 4. Okay, you need to be able to write the equations of the asymptotes.
Y, is y equals 4?
Because where did it originally start on that very first graph we did? At 0. It was y equals 0 was the asymptote. So you're shifting y equals 0 up 4. Yep. Yep. Okay.
Because I want to work, but I won't like
Okay, so I'm going to draw my asymptotes. And that's probably the first thing I do every time I graph one of these is make sure my asymptotes are on. Just because it gives me the boundaries, it helps me see where I can go and I can't go. Okay, so you guys like the table of value method the best. So we're going to dump in, so my asymptote for the domain cuts it at 2. So I know at 2 I'm undefined. So I'm going to pick values less than 2 and greater than 2. 0, -2, 2, and 4. No, I can't pick 2. What am I doing? 4 and 6. 4 and 6.
Can you sub it in the equation?
Substitute it in your transformed equation right here.
What if you have the transform one, can you still sub it in the other one?
So what I'm going to do, yes, you can substitute it in the other one. Yeah, it'll work. Because they're equivalent forms, right? So you can substitute it into the original one if you want, or you can substitute it into your transformed one. It really doesn't matter where you put it. So this will be -3/4. -3/4 plus 4. Positive 3.25.
No.
Miss Guy, once again, this would be easier if you went up by 1.
You're absolutely right. -1/2 and 4. You're going to have your calculator for the whole thing if that makes you feel better.
I asked you, and you said no.
I lied. It's only a 3 lesson one, so I don't have time to take your calculator away.
Are you gonna let us have an exam?
For 45 minutes.
That's it?
That's it.
Are you gonna have
All the questions will be up front. 1, 2, 3, 4, 5. Possibly 6 questions with your calculator, 45 minutes. No, that's your calculator portion. It's not. It's technically not.
Can you finish the whole test like this? A whole test like this? Exactly. You would have to cram, like you would have to go for.
Yeah, but there'll be doable questions within that 45 minutes if you know what you're doing. If you're grasping at straws, then you're pooched. Okay, did you guys graph that? I'm late to the show. Hey, Rin.
You doing a lesson right now?
Oh, yes.
Damn, like how long do these take?
There's so many pages. Look at that trade. Oh my god, we have so much left.
Oh, jeez.
Please put that into one
Today might not, it might not fit.
Can I ask you a quick question then?
Sure.
Do you want to rent me something?
For what? Which one?
What is it? Oh, what's it called? Campbell.
Done. Sorry. I'm already,
Hello?
I already gave it away.
To who?
Can't tell you.
Why not?
Cause somebody else already asked me.
I think Beck is for you, Aiden, if you want to try that one. Because I already took Sousa and Jacoby.
Oh, you took Susan.
Yeah, I did take Sousa. That's the first one I did.
Okay.
Kirkpatrick, Foley, Monroe. So there's a lot.
Okay. I'm gonna show it to you the other way. Page 1 rules. No, we did transformation form.
No, the one after. Oh, never mind, we haven't yet. I was doing like that.
Okay, this is the other way. Okay, so the first thing I'm going to do is I'm going to find where my vertical asymptote is, because that's the easiest thing to do. Yep, so vertical asymptotes. Vertical asymptotes are your NPVs. Takes me longer to write what it is than it is to do it. So I'm looking at the denominator. So I'm going to take x minus 2, set it equal to 0, and then solve. Okay. Step 2 is horizontal asymptotes. So those are our rules. So those are the rules that we memorize about the degree. And this, what are the degrees on this one? 1 and 1. So they're equal. So it's the leading coefficients on this one. So this is option B. So this is leading coefficient rule. So that would be y equals 4 over 1, which is just simply 4. So much easier. I dislike transformations a lot.
Wait, you prefer this?
So,
Yeah, because then now you can just take it into the table of values.
so, and now you just jump into the table of values.
It's not a lot at all.
And so again, like if I would graph those two asymptotes right away and just know the boundaries that you, when you're picking your x's, like I would leave like x equals 2 is undefined. So rules on page 1, transformation form. I'm going to be honest with you, I'm not going to tell you you have to do it one way or the other. But if I give it to you in transformation form, you need to know what you're doing with that. Does that make sense to everybody?
Yes.
Okay, good. Thanks, Nicole. Thanks for being my person. Okay. So there are many ways we can do this. You have to find the way that is emotionally good for you.
Are we gonna finish this last?
Not a chance. Not a chance. But that's okay. We're golden. We're golden. Okay. Let's do this quickly, and we're going to do it from the rules of page 1.
Both asymptotes.
Rules of... So, Basil, where are we? Sorry? Say that again.
Both asymptotes are 0.
Both asymptotes are 0. So my vertical asymptote,
Is it because, how do you find the vertical one though? Like,
that's your non-permissible value.
so it's just like.
Set your denominator equal to 0. What's the square root of 0? 0. Would it be plus minus 0? 0 is neither negative nor positive, so it's just 0. Okay? Horizontal asymptote,
Y equals 0.
how come?
The numerator degree is smaller than
Okay, so those are your degree rules, right? Done and done. Let's do, let's put those on our graph. So, but you still need to know how to deal if it's in transformation form. Because I'm going to give some to you in transformation form. So it's kind of like set notation. Like you don't ever have to write it in set notation, but you need to be able to read it, right? You need to be functional math students. You need to be able to read and be able to communicate in different forms. But when you perform it, I'm okay with whatever one you choose to do. So what are we going to do from here? We need some increments on there. And since I'm a creature of habit, I'm just going to keep going with what I had. Okay, I'm not even going to do a table of values. We're going to do it in our head, folks. You ready? Do we feel dangerous enough? Can we do this? Can we do it?
We're going up by one.
We are. Every tick is one. Oh, in your list. Okay, yeah, okay. Yeah, for sure.
We should.
Okay, maybe I should do a table of values. I was cocky there for a second, and then I'm like, okay, so we're going to go, can we do -4 just for funsies? Oh, -4 is bad, oh bad. How about -2?
Yes.
-2. -1, what's happening at 0? Undefined. 1 and 2, are we good with that table?
Yeah.
Okay. 1/4.
And then one.
And then 1.
And then one and one.
And then 1. And 1/4. Can we graph this?
Yeah.
Beauty. And I think what makes parabolas beautiful? Their symmetry. So the rational graphs are no different. What makes them beautiful is their symmetry. Oh, I'm going to lose another half mark. My 6 got erased, I'm sorry.
The timer already told me how to say it, so I don't know how I'm gonna do this.
So how do you feel about that? Okay. Which method do you like first? Transformation or page 1 rules? Oh, I'm people after my own heart. But alas,
Oh my god.
ooh, it's transformation form.
Oh, it's weird. I don't like that.
We have no time. We got 9 minutes. We can totally get this one done in 9 minutes.
It's not, why did it fix -15?
Ah, good catch, good catch. So what do we know? So let's flip this. Let's just flip this for a second. Would you guys agree that's the same thing? Okay. That negative, what does it do? Where? Brilliant.
We don't have time.
What do you mean? Any vertical stretch?
No.
No vertical stretch. That's nice.
Where's the vertical stretch again on the top?
The 1. I'm just going to write no vertical stretch. You don't have to if it doesn't make sense to you, but I just want to write it down just because it's a 1 and we'd be multiplying by 1s and that's... what do we got for horizontal shift? So 4 left. And a vertical shift?
So wait, there's never gonna be a horizontal stretch, I guess?
Stretch? Yeah, we're throwing B out the window for this. We're not there yet.
Are we getting
No, we're not getting there. Okay, so let's do the equations of the asymptotes. So this means, okay, can we graph it? Yes, we can. So I think you guys, as ugly as this unit can be, I think you guys are pretty okay. This is lesson 1. It gets better. It actually gets better because we're going to get to point of discontinuity tomorrow, which is super fun.
Well, we're done one third of the unit, I guess.
What? What?
We're done one third of the unit.
We're done a third. Well, not really because we still have the word problem to go.
Oh, you didn't have to say that word.
Okay, sorry. Okay. I'm going to throw in my asymptotes. Why are you going to throw up? Wow. Wow. You're going to have to do a table of values because, well, we're going to substitute them into the equation, right? What? I don't know what I'm waiting for. Oh. So what values am I going to pick? Does it matter?
Yes. Oh, what? Sky, why do you do this?
Just because I'm wild and crazy.
So that's gonna be 1 over 16.
What?
With negative.
Yeah, that's okay.
No,
That's okay. It's just going to be really close to the line.
It's okay for you.
Okay. All right. Are we ready?
Five and 15, 16.
Yeah.
Miss Sky, you have more pencils.
Yeah. I'll even give you a nice one.
Oh, mine is so tiny, and I left my mechanical one at home.
Okay. Okay, so everybody listen. We put -8 in here. -8 plus 4.
Negative 4.
Negative 4 squared. 16. So we're going to have 6 minus 1 over 16.
So 16 over 16 minus 1 over 16 is 15 over 16. Or, no, wait. Well,
Yeah.
oh,
Just like take the 5.
Oh, yeah.
5 fulls, leave 1 part.
Wait, doesn't that mean we're supposed to expand? Like, under 2?
You don't have to because we're substituting a value in for x. I mean, you could expand and then substitute the value in, but then you get to square something and then you get to times it by a coefficient and an x, so just substitute it in. But yeah, you're right, you would have to do that if we were leaving that as an x. Okay, we're going to put a 6 in there. A 6 goes in. I'm at -2. -2 squared is +4. So now we have 6 minus 1 over 4. 5.75. Okay, now we're going to put a -2 in there.
Well, is it a parabola?
What do we know? What makes parabolas beautiful? Symmetry. So what makes a reciprocal, what makes the rational graphs with them? Also symmetry. So if I put -2 in there, I'm at 5 3/4 again. And if I put 0 in there, 15 16. So what does that mean? I'm really, really close to 6. But I'm not touching it. So this point's going to be like really, really, really close to the line.
Wow.
-2. I'm going to be really, really close to the line.
That's familiar.
Oh, sorry, they should be on the same side. Ooh, -6. Yeah? I'm doing that wrong? How come? What did I miss? I missed the reflection completely.
What?
Oh, what did we miss? We did substituting it in, but then I missed the reflection completely.
I did it.
No, it should,
You just did your point.
I just did my points on the wrong side of the line, that's all. That's all. I graphed them the right way and then I was like, no, that side's wrong, and I fixed the